we have this example of a differential equation. It's from the K Pure Mathematics, May 2024, paper, question 6b. It says determine the general solution of, and what we have here is dy by dx plus 3 over xy is equal to sine 2x divided by x cubed. I'm going to ask you to pause the video, write it down, and make an attempt at it. Okay, you finished? Now, let us work it out. You have various ways of solving differential equations. This is a first order differential equation, ordinary differential equation. It doesn't seem like you can solve it by direct integration. Doesn't seem like you can solve it by separating the variables either. Right? I know that you can indeed solve it by using an integrating factor. Now, before we do that, let's just review what this integrating factor business is about. Remember the integrating factor? It applies to differential equations of the form dy by dx plus py equals q. So if you need to, you write it in this form, right? Let's call that step 1. All right. Then let's call this step 2 now. What you do, after you identify what p is, you multiply by e to the integral of p dx. Then after that, you call this step 3. This left hand side here, you identify what product you differentiated to get it, because it will be in the form of product rule when it comes to differentiation. So the left hand side is going to be the derivative with respect to x of a product. You write it like that. And then after that, you integrate the function. All right? So let's see what happens now. What we're going to do? Well, you already have it in the form p dy by dx plus py. P is 3 over x, right? Equals q. Q is sine 2x over x cubed. So p is equal to 3 divided by x. So therefore, e to the integral of p dx is equal to e to the integral of, well, it's 3 divided by x dx, because p is 3 divided by x. Alright? Now, what is the integral of 3 divided by x? The integral of 3 divided by x is the same thing as 3 integral of 1 over x dx. I should write the dx there. Is equal to 3 ln x. Well, you know that when you integrate, you put the constant of integration. But in this case, you leave it out. Alright? Or you can say you assume it to be 0. Alright, so in this case now, what you have is that e to the integral of p dx is going to be equal to e to the integral of, no, to the, you're integrated already. You wouldn't. When you integrate the 3 over x dx, we get 3 ln x. So it's e to the 3 ln x. Alright? Now, notice, if you have e to the ln of a function, then that will be the function. So let's try and write it like that. Let's use 3 e to the ln what? Well, if you remember your rules of logarithm, you remember that 3 times ln x is equal to ln of x cubed. So it's x cubed. You see the e to the ln, that cancels. So e to the integral of p dx is equal to x cubed. You see that? The e and the to the power of and the ln, they cancel, leaving x cubed. As if you have e to the ln of any number, you can try it with a calculator, you're always going to get back that number. Alright, so you have x cubed here. So you multiply both sides by e to the integral of p dx, which happens to turn out to be x cubed. We have dy by dx plus 3 over xy. Let's write that down. So we have dy by dx plus 3 over xy. What happens after that? Equals sine 2x over x cubed. Equals sine of 2x over x cubed, right? We're going to multiply both sides by x cubed. So what happened here? You multiply, let's put the x cubed here, and for this we have x cubed here, and for this we have x cubed here. What's going to happen now? Let's rewrite this. X cubed dy by dx plus, going to have x into x1, x into x cubed was x squared. So this becomes 3x squared y. You see that? Equals, well, x cubed cancel x cubed. So you have sine 2x here. Alright. So the next thing now, look at the left hand side carefully and see if you find a product that was differentiated using the product rule. Now remember the product rule, what it says is that you have d by dx of u d, oh no, sorry, yeah, d by dx of uv is equal to, you hold u as it is times differentiate v, dv by dx, plus you hold v as it is now, v times differentiate du by dx. Alright? So this is the product rule. How does it apply to this? Let me see. It seems you differentiate y here. So if you differentiate here, you would have held x cubed. So if you hold x cubed here and differentiate y here, then you should hold y here and differentiate x cubed. Now it seems like you did hold y as it is. When you differentiate x cubed, you have 3x squared. So that is it. So what you have here is the derivative with respect to x of a product. What's that product? It was y times x cubed. Alright? Or let's write it as x cubed y. And that is equal to the sine of 2x. Alright. Now the next thing, you integrate both sides. The integral of d by dx of x cubed y is equal to the integral, dx is equal to the integral of sine 2x dx. Alright. Now when you integrate the derivative, it's like the integral and the derivative cancel each other, leaving the number or the function undisturbed. So what you're going to get here is x cubed y equals. Alright, now you need to integrate sine 2x dx. So you find the integral of sine 2x dx. Now, you know that the integral of sine x, when you differentiate sine, you get cos. When you differentiate cos, you get minus sine. So if you integrate minus sine, you get cos. Alright, I'm just trying to remember the table of derivative. If you have it, the table of derivative in front of you, no problem. Now, here, if you had integral of sine x dx, what you will get is negative cos x. But it's sine 2x that you have. So you remember what to do? When you have sine 2x to integrate, you can use integration by substitution. But if you do it enough, you would remember that this is going to be negative cos x over 2. Alright? But just in case you don't remember, let's look at it. So let u be equal to 2x. Then what you're doing here is finding the integral of sine u dx. But you want sine u du. So let's see what you do now. Let's differentiate this. You say du by dx is equal to 2. So what is dx? Dx is going to be du over 2 when you transpose this to make dx the subject. So what we have is the integral of sine u du over 2, because dx is du over 2, right? Du divided by 2. So it is really half integral of sine u du. When you integrate sine, we run out of scrolling space. Let me draw a line and continue it up here, because we cannot scroll down anymore. So let's continue the work here. Alright, so what we have? Half integral of sine u du. So it's half sine cos sine cos oh, is, yeah, when you differentiate sine you get cos. So when you differentiate cos you get minus sine. So when you differentiate minus cos you get sine. That means you integrate sine you get minus cos. So it's going to be half times negative cos u plus c. Alright, but u was what? U was 2x. So let's write it as cos 2x plus c. Alright? So that's what we get. Now, let's write back all of this. X cubed y equals. So, what we have here is x cubed y equals x cubed y equal the integral of sine 2x. So it is equal to negative half cos 2x plus c, equal to negative half cos 2x plus c. Alright? You can see it from here. This is it. When you integrate half sine u plus c, sine u du, you get negative half cos 2x, because u is 2x plus c. Alright? So that's what we have. So we can say, when we divide both sides by x cubed to make y the subject, y is equal to negative half x cubed cos 2x plus c divided by x cubed. So that's one way to put it. Alright? So this is our solution.